Hello class, and welcome to the notes on hyperbolas, notes for worksheet 6. So we will be graphing hyperbolas in this section, and I'm going to be drawing a lot of similarities to an ellipse. Clearly, it looks very different from an ellipse, but there are a lot of things similar, starting with the way that the equation looks. I mean, just take a look at it. It looks exactly like the equation of an ellipse with one small difference, and here's the difference. There is a minus sign instead of a plus sign. So in order to be an ellipse equation, we're talking about a common difference. In other words, there must be a minus sign between the two fractions. Unlike ellipses, the x or the y can come first. Sometimes the x comes first, which tells me the direction of the parabolas in the hyperbola, or the y comes first. So in ellipses, the x always comes first. And then this is another big difference. The a value is always under the first fraction, which means that sometimes it's not the biggest number in these problems. Didn't mean for the pen to be that thick, but you get the idea, okay? It is not always going to be the biggest number. So when it comes to ellipses, okay, how do we know the direction? Well, like I said, with ellipses, the direction is determined by the larger number. That's not the case here. If the x is the first letter in the fraction, that tells me that I'm dealing with a horizontal hyperbola. Okay, so feel free to pause this video and get these notes down. I'll give you a time to do that once I'm done talking. And then this is a little side note. The number under the x is going to tell me the side-to-side length from the center when I'm making the box to graph, which right now doesn't make much sense, but it will when we're graphing, okay? And then likewise, the number under the y tells me the up and down length from the center. And if the y fraction is first, then the hyperbola is vertical. And when I say vertical, I mean that the parabolas, because a hyperbola looks like a back-to-back parabola. When we're vertical, the parabolas open up, and when we're horizontal, the parabolas open side to side. So that's the difference between horizontal and vertical. So this might be a good time to pause the video and write down all of these notes. So if you've already written down all of those notes from pausing, I'm going to talk through these for a minute. So the center is always HK. Change the sign of the x, change the sign of the y, just like in a circle and ellipse. Now the vertices are the vertices of the little parabolas. I'm going to ask you for those ordered pairs. There's one way just to eyeball it, which is probably the easier way, which I'll show you when we're graphing, but there is also a formula. If the hyperbola is vertical, then the formula comes like this. You take the center, so HK, and then to the y value, we're going to add and then subtract the value of a, and that will give me my ordered pairs for the vertices. And then if it's horizontal, we take the center, HK, and we add or subtract the a to the x value. Okay, so it's h plus or minus a, comma, k. There are two axes, like the major and minor, but they are called the transverse axis and the conjugate axis. The transverse axis connects the vertices of the parabolas. The formula for that is 2a. The conjugate axis is the other axis. It's perpendicular to the transverse, and the formula for that is 2b. And I will talk about those when we graph once again. So lastly, we are going to be finding a C value to locate the focus points, and the focus points, or the C value, come from the distance from the center to the focus points, okay? And instead of doing a squared minus b squared equals c squared, that's an ellipse formula, it should be a plus for this, okay? So I'm going to change that and I'm going to leave it another color because it's that important. A squared plus b squared equals c squared is the formula to find the c value of a hyperbola, okay? And so that is different from an ellipse because with the ellipse, it is a squared minus b squared. The way I remember it is since the original problem has a minus in the original equation, the C formula has the opposite sign, a plus. And then to actually find those points, if we have a vertical hyperbola, I'm going to add the C value to the Y value of the vertex. If I have a horizontal hyperbola, I'm going to add the c value to the x value of the vertex. So again, if you need to pause and get anything else down, that's it. But right now it might not make a lot of sense. You might be like, that's a lot of information. I don't get what she's talking about. Well, let's do a couple graphs together and I think it will all come together. Starting with example 1. The first thing my eyeballs do is look at this. This is the minus sign in between, which this is what tells me I'm dealing with a hyperbola. Okay, then my eyeballs go to this. The letter that comes first is the y, which makes this a vertical hyperbola. Okay, so let's write that down. Let's write that down. The y fraction comes first. And that is what tells me that I'm dealing with a vertical hyperbola, which is going to open up and down. All right, so it does not matter the size. The a number is not automatically the bigger number. The a number will always come first. So this square root of 4 is 2. That's my a value. So just think about it in alphabetical order. First comes the a, then comes the b. Square root of 9 is 3, so that's the b value. And finally, the center of this, now you have to be really careful when y comes first. Here's why. The center is actually -1, +2, okay? -1 comes first because that's the x value of the vertex, so be really careful. -1, +2. A lot of the times we go to -1, we just go in order. Okay, but you have to be careful. The number grouped with x is the x value. The number grouped with y is the y value. So -1, 2 is right here. Before we do the rest of these blank spots, I'm actually going to have us graph the hyperbola. So go ahead and plot the center. And you guys, I think it's easiest, instead of looking at a and b and looking at this information, I forget about it because sometimes the a and b part confuses me. I just look at the equation to graph. The number under y always indicates how far to go up and down. So even if the y was over here, it would still indicate up and down. So from the center, the square root of 4 is 2. I am going to go up 2 and down 2. And again, the reason is because the 4 was under the y, which indicates vertical movement. Whereas the 9 is under the x, which indicates horizontal movement. So the square root of 9 is 3. So from the center, I'm going to go left 1, 2, 3, and right 1, 2, 3. Now, if this was an ellipse, I would draw my oval, but this is not an ellipse. Instead, what I'm going to do, and this is kind of weird, but I'm going to make a box that contains all of these points. So instead of making an oval, I'm going to actually make a rectangle. And that's what I meant by make the box. And then, again, strange, but this is what you do. You're going to make an X through the box that goes corner to corner. And it should go through so that you actually create these like almost diagonal asymptote type things. Okay, so I make it really long and then I just kind of move it so that it's centered. Okay, so this is a guide for us to draw the hyperbola. So we're going to follow the yellow brick road. The hyperbola is vertical. So this is actually the vertex of the hyperbola. And I'm using those dashed lines. Uh-oh, it should correct it and make it look pretty. Let's try again. Uh-oh, lots of issues going on. So let's try that again. Shouldn't correct it. There it is. That's nice. Those yellow lines kind of guide me in terms of how wide the hyperbola or those parabolas should be. Okay, so it's just a guide. It doesn't have to be perfect, but it really should help you figure out how to draw this correctly. So I'm going to kind of fix that one a little bit, but that looks good. It just kind of is a guide. But you do want to draw it. I want to see those dashed lines there. Okay, there we go. And that's it. Now, that's it in terms of the parabola parts. I still have to graph the focus points. So I'm almost done. Let's talk about the vertices. So there is a formula for that. The vertices, since this is a vertical hyperbola, the formula is h comma k plus or minus a. The H value is -1. The K value is 2, plus or minus the A value, which is 2. So I could use the formula to find these points. -1, 2 plus 2 is 4, and -1, 2 minus 2 is 0. But I also could just eyeball it. Like this point is legitimately -1, 0, and this point is legitimately -1, 4. So I don't care if you use the formula or if you eyeball it. You do have to use the formula for the C value, which is A squared plus B squared equals C squared. So A squared is 4 plus B squared, which is 9. So C squared equals 13, which gives me my C value at square root of 13. You could put plus or minus, but it's technically a distance. So this is about 3.6. So from my center, okay, I'm going to count 1, 2, 3.6. So like in a little bit more. And that's my focus point. You count from the center. 1, 2, 3.6. And there's the graph. I'm done. I just have to fill out a couple more things and then we can move on. So for the focus points, we moved up and down. So the formula is H comma K plus or minus C, -1 comma 2 plus or minus root 13. Those are the focus points, and transverse axis is 2A. So 2 times 2 is 4, and conjugate axis is 2B. So 2 times 3 is 6. Now if you're wondering what does that actually mean, the transverse axis is this length from vertex to vertex. The conjugate axis is this length. So think of it as almost like the height and the width of the box. And that's it. Feel free to pause, get everything down, or backtrack if needed. But I'm going to move on to example 2. Last but not least, this time my eyeballs go to the minus in between. That tells me it's a hyperbola. Then my eyeballs go to the first letter. This time the first letter is X, which tells me this is going to be horizontal. So the first fraction, I'm sorry, the X fraction, let's write it that way, because that's how I worded it above, comes first. And that tells me I'm dealing with a horizontal hyperbola side to side. Square root of 16 is 4. That's my A value. It's always the first one. Square root of 25 is 5. The center, the number with X is -3. I changed the sign to +3. There is no number with Y, so that's a 0. And at this point, I'm going to graph. So I'm going to plot the point 3, 0. Look at the fraction. Look at the fraction. Underneath the X is 16. Square root of 16 is 4. And since that's under the X, that tells me to go sideways 4 and left 4. Okay, and then under the Y is the 25. So square root that, that's 5. So I'm going to go up 5 and down 5. 1, 2, 3, 4, 5. I'm going to draw the box. Uh-oh, it kind of was off there, so let's fix it. There it is. Draw the diagonals of the box with some extra length. Beautiful. Now I can draw my hyperbolas, which are going to go side to side. So here's the vertex of this part. Beautiful. We use the yellow brick road as a guide. Oh, come on. There we go. Beautifully done. So I'm just looking for you guys to give me, you know, a sketch. Obviously in Class Kick, it's going to be a little bit more difficult to draw something looking really nice. But this is plenty good. There it is. Okay. So the vertices, I could eyeball it or I can use the formula. And if you are a formula person, just don't forget that this time the vertices go left and right. So we're adding the a value to the x of the vertex. So 3 plus or minus 4, comma 0. The a value is 4. 3 plus 4 is 7. 0, that's 1 point. 3 minus 4 is negative 1. And again, we could have just eyeballed that. As far as c goes, a squared plus b squared equals c squared is 16 plus 25 equals c squared, which is 41, equals c squared. So c is the square root of 41, which is approximately 6.4. So the focus points are going to be h plus or minus c, comma k, which is 3 plus or minus root 41, comma 0. So from the center, I'm going to go 6.4. 1, 2, 3, 4, 5, 6.4. And from the center, 1, 2, 3, 4, 5, 6.4. There's my hyperbola, major. Oh, this is transverse and conjugate axis. That was a typo. But the transverse axis is still 2a. So 2 times 4 is 8. And for the conjugate axis, 2 times 5 is 10. So there we go, you guys. Feel free to pause, go back, re-watch. But that is how we graph hyperbolas. So thank you for your attention to this lesson. And please go practice on worksheet 6.